There won't be any of the isomorphic mappings on there. No subgraphs, even though we didn't learn in class. But like I said, there was that question that I accidentally put on there. So don't worry about subgraphs. I guess the walks and all that stuff, they're not difficult. But I didn't put. Oh, that's right. Euler circuits and Hamiltonian circuits. Make sure you guys knew that. Okay, so. Give an Euler or Hamiltonian circuit. So I'll go back through the exam review and take a look, okay, just to make sure that there's nothing I might have missed. But on the exam review, if you guys are working some of the problems, okay, something like 24, make sure you guys go back through that. 25, 26 is fair, 27 is fair, 27 might be fair. Oh, there's two 26s. I'll just do them both. That goes for the same thing with the exam. If there's two of the same number, make sure you do them both.
It's a nice technique to make us think it's shorter than it is.
Yeah, isn't it? So kind of sneaky of me. My bad. Although neither of the 26s are too difficult. So
Number 27 is just like, it's like a line with 5 vertices, right? 6 vertices, right?
which one?
27? No.
Well, it could be. It's all the non-isomorphic trees. Okay. So one of them would be like a line that has 6 vertices.
The other one could be like a K, the one with the 3.
Yeah, you could have like one with 3, one with 4, one with degree 5. Okay, so there's a lot of different of those you can make. Okay, in fact, for that one, I think there might be something like 8 or 9 different trees you can make for that.
On the exam, will we most likely have a problem that has like 8 or 9 trees, or like
No,
the
no,
two
no,
that
no,
we
no.
had in class?
I'll keep it to like, if I do the non-isomorphic ones, I'll keep it to 3, 4, 5, 6. Okay, I'm not going to
Okay.
make you guys do one that has. I mean, I'm not trying to waste your time with problems that are time consuming. Okay, it's basically like, do you know it or don't know at this point? Okay. All right, so that should keep you guys entertained for a couple hours. All right. Anything that I didn't write on the board, don't worry about. I promise it won't be on there. All right, so before I take any questions from you guys, let me remind you of like what you can use. Oh, by the way, for this question right here, make sure you have the sheet for this. So, for the final, you're going to need those 3 worksheets. Okay, so. So let's talk about the references you guys will probably need for the final. Okay. So there were those 3 help sheets that I asked you guys to have. Yep, those 3 right there. Okay. So your 3 help sheets, or your 3, I guess, rules sheets. And just to remind you what those are, that's the one with the Boolean algebra. Okay, so Boolean. We had the one with the sets, and then the one with the closed forms of sums. So if you don't have those 3, make sure you go on Blackboard and print them out. Okay, so you don't want to lose 4, 5, 6 points just because you can't do those sorts of things. Okay, those are the ones. Okay, obviously calculator, blank paper, pencil, and then I think I told you guys if you want to, you can use the 3 index cards from your first exams. Okay, and then you can introduce a new index card of 3 by 5, or if you don't have those, just take a half a sheet of paper. And you can just rip it in half and just use both sides if you forgot what everything was, okay? If you lost your note cards, okay? I don't care which way you guys do it, okay? Because quite honestly, the time you guys spent for those original note cards was probably a lot more time than you guys would making up another one of those sheets. So, 2 options for, I guess, the note cards. You can use, the 3 note cards from exams 1, 2, and 3, plus 1 more 3 by 5 note card. Okay. Or, like I said, if for some reason you lost those note cards, okay, what you could do is just rip an 8.5 by 11 sheet of paper in half and just use both sides of that.
So that's. If we're going to use the first 3 note cards, it has to be the 3 original ones?
The 3 original ones, yep.
Okay.
That's why I always ask you guys to bring them up so I can staple it to everything. So if you lost it, that's your business. That's not mine, sorry. All right, so Another option, and I'm gonna put up here, or, okay, so you'll get to use both, sorry. Or you can use 1/2 sheet of 8.5 by 11 paper.
You said that size.
Hold on, let me check, just to make sure. I don't wanna give preference to one or the other, although it really doesn't matter.
So since we are using or, so we can use both of them, right?
No, sir, or does not mean both. I actually just said that. I said you do not get to use both. Sorry about that. Yeah, it would actually be one side, sorry. Because if you use that, basically the area is almost the same, so. Sorry, I meant to measure now. So 1/2 sheet of 8.5 by 11, one side. Okay. All right, so you can use that for reference if you guys want to. Okay, so one or the other, not both. I'll post this on Blackboard to remind you guys. So, everybody clear about references? Any questions, Lucas?
Sorry, I thought we could use both sides of the note cards.
You can, yes, that's correct. So it would probably be better just to use the note cards. But since I streamlined like all the information, so there's going to be stuff that you wouldn't want to put on the note card or on the, I guess, the sheet. So I think that's fair. Okay. All right. So any other questions about the references that I can answer for you guys? About anything? Okay. What about any specific problems that you guys thought might be problems for you guys if you were looking at what we have up here? What looks like it might be difficult / impossible /
Can you do number 27? For
Can I? I
Yeah.
can.
Let's look it up. The
Do you want me to
possibility.
do it on the board?
If you can, if there's.
I can.
Okay, thank you.
Doesn't mean I will.
May you?
I may. I think what you're saying is please do number 27. Right.
Yeah.
I can do that. Absolutely. I'm just messing with you. Yeah, this is actually a really sneaky one because it looks like it's pretty innocent and it's not all that nice. So number 27 up here says list all the non-isomorphic trees with 6 vertices. Okay, so one of them, obviously, the easiest one, would be this guy right here. Okay, so that's a tree, it has 6 vertices, it's not isomorphic. Okay, so if the problem's worth 5 points, I at least give you 1 point because you can draw a line. Okay. Another non-isomorphic graph would look like this. So that would be another non-isomorphic graph for that. Okay. Another non-isomorphic graph that looks very similar but is not isomorphic to that would be this. Okay, so I want you to notice that these 2 graphs are not isomorphic to one another. Okay? They look very similar, but they are not. Okay? By the way, this graph would be isomorphic to this graph. So these 2 graphs would be exactly the same thing. Okay? I don't want you guys thinking that all I'm doing is I'm just moving the one that's jettisoning down each time. Because notice that all you'd have to do is just spin this thing around 180 degrees and it would actually be isomorphic to that. Okay, so does that make sense, guys, as to why these 2 graphs are not isomorphic, but these 2 would be isomorphic? Okay? The difference is that this guy, you'd have to do at least 2 traversals from an end to be able to get to that one that's jettisoning in the middle. Okay? So this, and the way I usually do it is I look at the maximum degree. Okay? So the maximum degree of either of these graphs is 3 of any vertex. Now I want to look at maximum degree 4. Okay? So I could do this. So 1, 2, 3, 4. So that's a graph that would be non-isomorphic to the other ones that I've constructed. Okay. Another one would be basically like the big old plus sign. That would be non-isomorphic if I were to do that. Okay. So in other words, this animal right here. Actually, you know what? I think that would be isomorphic if I did that.
Yeah.
Yeah, it would be. All right, so then we can just do the cluster. All right. And I think that would be all of the non-isomorphic graphs of all the non-isomorphic trees with 6 vertices in it. Okay.
That one is 5 vertices.
Right. This one, if you swung it around, it would still look the same. Okay.
No,
So
but the plus sign is 5, right? 1, 2, 3, 4.
right, and then I'd have to stick something else on there, so I couldn't
Okay.
do the plus sign for that one. Okay. All right. So does that make sense, Art, for that? Okay. Yeah, it's like one of those things where you just draw it out and you just do your trial and error, quite honestly, and you just look to see if, like, you rearranged it, it will look the same. Okay. All right. So were there any other specific questions, either on the exam review or anything else that you guys might have seen somewhere that might be difficult for you to answer or anything like that? It might be one of those things where now that you guys know what to expect, you might have to go back home and review stuff at this point, just because, you know, you might not even know like which questions you have until you're working through it. I don't know. So, if you guys can find something, let me know. So, John?
Yeah, in proving like by induction a divisibility, I guess the one in particular, all n is an element of z, n is greater or equal to 0, 7 divides in parentheses 9 to the n power minus 2 to the n.
Oh, yeah. Everyone loved this one. Okay. John, is it okay if I just go through the inductive part of that, since where you put in the k plus 1?
Yeah.
Okay. Because I'm assuming most people would be able to do the basis step, right? Like if you plugged in 0, you could do that, and then you could assume it true for the k plus 1. Okay, yeah. A lot of students didn't like this one too much, so let me go ahead and show you what to do with this. So, you would go through, you would do all the easy stuff. Somewhere up here, you would say that 7p is equal to 9 to the k minus 2 to the k. Okay, so you have to say that somewhere up top. That's really the only thing you really need to bring down to make those work. Okay, so you go back, you do your inductive step, you do your basis step, and you do your inductive hypothesis. Now you plug in k plus 1, okay, for n, bless you. So let n equal k plus 1. Okay. There's actually a number of ways that you can do this. Some of you guys were really slick on the homework at the exam with this. Okay. So you would get that 9 to the n minus 2 to the n equals 9 to the k plus 1 minus 2 to the k plus 1. Now this is where you guys had to go through and you had to use a little bit of algebra magic and exponent rules. Okay, so let me remind you guys of the technique for this, or maybe somebody can remind me of this. So, does anybody remember the trick at this point?
Yes, 7 and 2.
Specifically what, Art?
For the 9, you can do split it into 7k plus 1 plus 2k plus 1, like that, right?
Oh, I see what you mean. Unfortunately not. That's not an algebra rule that you can use. You're close. You're on the right track. You're going to break it up into 7 and 2, but
You just make it 7 plus 2 times 9 to the k.
okay, so, or before you do that, write it like this. 9 times 9 to the k
Oh, yeah.
minus 2 times 2 to the k. Okay? Remember that exponent rule, guys? We can just pull off one of the 9s and put it in front, pull off one of the 1s and put it up front.
Yeah.
Now you can use that trick,
7, yeah.
where instead of 9, you write that as 7 plus 2. Instead of 2, you guys could either leave it as 2 or you could write it as 1 plus 1. Okay? And I'll show you guys why we might want to do that in a moment. Okay? So this would be equal to, instead of 9, 7 plus 2, 9 to the k, minus 1 plus 1, 2 to the k. Actually, you know what? We don't even need to do this. I'm going to try to do this the most expedient way. We can leave this one, that's good. I'm just going to leave this like this, just to make it a little bit faster for us. Okay. So, is that okay with everybody, guys? I didn't, just like some exponent and then breaking it up. okay? Now what we're gonna do is we're gonna distribute the 9 to the k, and then we can go ahead, we can almost do the induction from there. Okay, so let me go over here and do this. Okay, we're about 2 or 3 steps from finishing this one off. So we're going to distribute that 9 to the k. So be careful with this. Okay, some of you guys made some algebra errors, and you wrote it as like 7 times 9 was 63. It's going to be 7 times 9 to the k plus 2 times 9 to the k minus 2 times 2 to the k. Okay, so that's just distribution. So everybody see that, guys? Any questions? Okay. Now what you guys will notice is that we almost have like a 9 to the k minus 2 to the k. Okay? So we have a 9 to the k minus 2 to the k. The only thing that's bothering us is that there's a factor of 2 in there, right? So couldn't we just factor out the 2, and then we can use the inductive hypothesis? Okay, so I'm going to factor out a 2. I'm going to be left with 9 to the k minus 2 to the k. And right there inside of that, you get 2 times 7p by this inductive hypothesis. Okay, so remember, guys, a couple steps back, you have to define that something like this would be equal to 7 times a number by definition of divisibility. Okay, so make sure you guys go back through. I think it's the worksheet that we did as well as the exam, because I think there was a question similar to that on there. Okay, so this would be equal to 7 times 9 to the k plus 2. This becomes 7p. That's the induction step. All right. And guys, what you'll notice now is that both of those terms have a factor of 7 in it, right? Because remember, we're trying to show that it's divisible by 7. Let's pull out the 7.